Welcome to the deep dive. We are really thrilled you could join us today because we have a genuinely fascinating journey mapped out for you.
Yeah, a really incredible one.
Our mission today is to explore this startling discovery made recently under a melting Russian glacier. We're going to figure out how massive biological remains ended up trapped there.
And more importantly, what this strange graveyard reveals about our planet's past.
Right.
And its very immediate present. Because we are looking at a rare intersection of glaciology, paleontology, and climate science.
All wrapped into one visually striking event.
Exactly. It offers this unique window into the volatility of Earth's systems.
And our roadmap for this comes from a highly detailed report. It was published on a Patreon page called KULT.
Specifically from a collection they run called nombre, elefante, right?
Yeah, that's the one.
Yeah.
They curated the field notes, the quotes from the researchers, the satellite data, basically all the raw puzzle pieces we need to reconstruct this event.
It's a great compilation.
It really is. So, to start, I want you to set a scene in your mind. Imagine you're walking across a freezing, remote island high up in the Russian Arctic.
That's lovely.
Right. The wind is howling, the landscape is utterly desolate, and then suddenly you look down at a newly exposed stretch of land and you stumble upon a prehistoric whale graveyard emerging from the melting ice.
The visual of that is staggering. I mean, mostly because it defies our baseline expectations of what belongs in a glacial landscape.
Yeah, whales and glaciers don't usually mix in our heads.
No, they don't. But researchers from the Russian Arctic and Antarctic Institute, the AARI, recently confirmed this exact scenario.
And we are talking about the Franz Josef Land archipelago here.
Specifically, a highly remote location called Wilczek Island.
Right. And the way the ARI specialists found this, it's a real testament to modern remote sensing.
Yeah.
They weren't just trekking across the archipelago hoping to trip over anomaly.
No, they were conducting a dedicated, highly systematic study of the region's permafrost dynamics.
As part of that research, they cross-referenced the current physical margins of the island's glacier with high-resolution satellite imagery. And that imagery was taken less than 20 years ago.
Which, in glaciological terms, 2 decades is a vanishingly small window of time.
Just the blink of an eye.
Literally. You might model a gradual retreat of the ice margins. Perhaps some predictable thinning at the edges based on seasonal thermal fluctuations.
But the satellite data revealed a structural failure, far more dramatic than a simple linear retreat.
Much more dramatic.
Okay, let's unpack this. The analysis of those satellite images allowed the researchers to see that a drastic change in the ice mass had occurred.
The ice sheet didn't just pull back.
No, it fundamentally fragmented. It sheared and split entirely into 2 separate sectors.
And when that massive physical rupture happened, it suddenly laid bare a surface area of several square kilometers.
Several square kilometers that had been completely shielded from the atmosphere for thousands of years.
Yeah, exposing that much subglacial terrain in a single rapid sequence is a violent geological event. It's huge. The fragmentation peeled back the ice to reveal a previously hidden marine terrace.
So not just bare bedrock.
No, not bedrock. They were looking at an ancient coastal profile, a raised terrace of marine origin that had been geologically lifted above the current sea level.
And it was on this newly emerged marine terrace that the AAR scientists found the prize. Scattered across this barren, newly exposed landscape were numerous massive bones of large cetaceans.
Whales.
Huge whales. The field imagery is almost surreal. You have researchers standing in heavy Arctic gear, navigating around these enormous biological remains.
That look completely alien against the backdrop of a fragmented ice sheet.
Exactly.
What's fascinating here is the sheer preservation quality of these remains. We aren't talking about highly degraded, fossilized fragments that have been exposed to standard weathering processes.
Because they were essentially frozen in time.
Precisely. Because this terrace was hermetically sealed beneath a massive ice sheet, and because many of these skeletons are still partially embedded in the permafrost at the margins of the remaining glacier.
The thermal dynamics kept them in a state of suspended animation.
The enduring deep freeze conditions essentially halted bacterial degradation.
It is like unlocking a prehistoric vault. The permafrost provided a perfect oxygen-deprived environment. But, that naturally leads to a massive logistical question.
How do they get there?
Right. How does a pod of prehistoric whales end up stranded on an elevated marine terrace, only to be subsequently buried under a glacier?
It's quite the chain of events.
It is. And the source provides some crucial analysis from Nikita Demidov, a researcher with the AARI. He points out that finding these marine giants in this specific stratigraphy indicates an extremely rapid episode of sea level change in the northernmost archipelago of Eurasia.
Yeah, Demidov's assessment points to a sudden, violent shift over the last few thousand years. To understand the mechanics of a stranding at this elevation, we have to look at the relationship between eustatic sea level drops and isostatic rebound.
Let's break that down a bit for everyone.
Sure, so for cetaceans of this mass to navigate those waters, the relative sea level had to be significantly higher.
Okay.
Then the environment experienced a catastrophic pivot. Either the ocean volume dropped rapidly,
That's the eustatic drop.
right, or the continental crust, which was freed from a previous heavier ice load, bounced upward in a rapid isostatic rebound.
Literally lifting the seafloor out from under these animals.
Exactly, lifting it right up. And once they were stranded on the newly formed terrace, a severe climatic cooling phase triggered the formation of the glacier over top of them.
Locking the entire event in ice. That is wild. The report notes that the scientific community is still working on the exact taxonomic identification of the species.
As well as the absolute total number of remains at the site.
Yeah, but the preliminary images clearly show several enormous specimens. We're looking at a pod of apex marine mammals that were caught in a brutal, rapid environmental shift.
And instantly archived by the climate. Wilczek Island is rapidly becoming a focal point for Arctic paleontology because of this.
Because it offers an undisturbed, high-fidelity snapshot of a specific, catastrophic environmental shift.
Right. But to understand why we're suddenly granted access to this snapshot right now, we have to examine the thermal trigger that forced the ice sheet to fracture.
Here's where it gets really interesting. The trigger for exposing this ancient paleontological site is entirely modern.
Unfortunately, yes.
This graveyard was revealed purely as a byproduct of the accelerated global-scale loss of ice. The glacier on Wilczek Island splitting down the middle is not a localized anomaly.
If we connect this to the bigger picture, the fragmentation on Wilczek Island serves as a localized macroscopic symptom of a staggering global trend quantified in the source material.
And the numbers are huge.
Massive. Between the years 2000 and 2023, the glaciers of our planet lost 6,542,000 million tons of ice mass.
That number requires a moment to fully process. Over 6.5 million tons of ice lost in 23 years.
It's almost incomprehensible.
It is a figure that is almost too large to contextualize without breaking it down into specific regional impacts. And the report firmly ties this unprecedented mass loss directly to the current trajectory of global climate warming.
The sheer scale of that metric is critical for you to grasp the velocity of the environmental shift happening around us.
We usually think of these things happening so slowly.
Right. The discourse around glacial degradation typically focuses on the forward-looking consequences. You know, altered global albedo, disruption of thermohaline circulation in the oceans.
And rising sea levels, of course.
Of course. But the ARI's discovery introduces a retrospective consequence. The accelerated melting is functioning as a geological time machine,
Stripping away the ice.
rapidly stripping away the cryosphere to reveal biological vestiges and climatic data that have been insulated for millennia.
So what does this all mean? How does the Wilczek enclave fit into the broader historical record of similar discoveries?
It helps to have a baseline.
Yeah, to really evaluate the rarity of this event, our source provides two other documented examples of what we could call whale graveyards.
Comparing the mechanisms behind these different sites gives you a much sharper sense of scale and context.
Let's look at the first comparison, the Atacama Desert in Chile.
The Cerebalena site.
That's the one.
It's a...
What is commonly known as a red tide.
Exactly. The cetaceans ingested lethal neurotoxins, died at sea, and were washed into a supertidal flat.
And then what preserved them?
Over millions of years, tectonic uplift slowly elevated that tidal flat, and the extreme aridity of the emerging Atacama Desert preserved the bones.
So it was a biological poisoning preserved by slow geological uplift and a total lack of moisture.
Which is very different from a rapid freeze under a glacier.
That gives us a localized biological event preserved by millions of years of slow tectonic movement. Now let's pivot to the second example from our source, which brings us back to the Russian Arctic.
But under entirely different historical circumstances.
Yes, this is Yitigran Island, home to the internationally recognized site known as Whalebone Alley.
The visual profile of Yitigran Island is completely unique. It was documented extensively during the Soviet era.
And it presents a very different spatial arrangement than what we see on Wilczek. On Yitigran Island, you aren't looking at the random distribution of a natural stranding.
Not at all.
You have massive bowhead whale skulls, mandibles, and jaw bones, deliberately engineered into the landscape. They're driven vertically into the frozen ground, standing like brutalist monuments along the coastline.
It's quite a sight. The source highlights that this was undeniably the work of the indigenous Yupik people.
Right. It wasn't natural geology.
The anthropological consensus suggests Whalebone Alley was constructed centuries ago as a highly organized communal space. The Yupik people likely utilized this specific coastal architecture for processing and caching massive quantities of meat in the permafrost.
A giant freezer, essentially.
Exactly. And the site almost certainly held profound spiritual and ritualistic significance. It is a masterpiece of early human interaction with apex marine biology.
Showcasing how ancient populations harvested and utilized these animals to survive in a hostile environment.
Which perfectly frames the scientific value of the newly split glacier on Wilczek Island.
Because Wilczek is completely natural.
This raises an important question. Why does the Wilczek enclave command such immediate attention from glaciologists and paleontologists when we already have these other extensive sites?
And the answer lies in the specific variables of its creation and exposure.
Right. Unlike Whalebone Alley, Wilczek is devoid of human intervention. It is a pristine, naturally occurring data set.
And unlike the Atacama Desert, which took millions of years of slow tectonic uplift to emerge and was found entirely by accident during a modern infrastructure project.
The exposure at Wilczek is an acute, real-time consequence of the current warming of the Arctic.
It is the ultimate convergence of natural history. You have a sudden prehistoric geological event, either a rapid eustatic drop or an intense isostatic rebound that strands the pod.
Followed immediately by a severe climatic deep freeze that locks the specimens in an anaerobic vault.
And now, several millennia later, a highly aggressive modern warming phase fractures the ice vault wide open, serving the data up to modern remote sensing technology.
The brevity of that exposure window is what makes the work of the ARI so critical.
Because it won't last forever.
No. The permafrost is the only reason these biological structures survived intact. It prevents the moisture and oxygen required for microbial decay.
So by arriving at the precise moment the glacier fragmented, Nikita Demidov and his team are intercepting these skeletons as they saw out of the active layer of the permafrost.
If the thermal degradation of that glacier had happened a century ago, standard atmospheric weathering and scavenging would have long since reduced those pristine skeletons to dust.
The very thermal dynamics that are currently unearthing these invaluable relics for the AARI scientists are the exact same forces that will rapidly destroy them if they aren't fully excavated and stabilized.
The thawing permafrost provides a fleeting window of observation before the environment reclaims the data.
It creates a fascinating paradox for climate-driven paleontology.
It really does. The accelerated thawing of the Eurasian Arctic is granting us unprecedented high-definition access to the biological history of the region.
The physical evidence of such rapid, localized sea level changes over the last few thousand years provides essential baseline data for fluid dynamic models and paleoclimatology.
Because understanding that the Earth systems were capable of shifting fast enough to strand a pod of massive marine mammals thousands of years ago gives us a vital framework.
A framework for understanding the elasticity and the extremes of our planet's mechanics.
Yes. The scientific yield is invaluable, but the mechanism delivering that yield is deeply concerning.
The numbers don't lie.
The source material forces us to confront the math. The loss of over 6.5 million tons of global ice mass, coupled with the violent structural fragmentation of an Arctic glacier in under 20 years.
It demonstrates that the fundamental architecture of the cryosphere is failing in real time.
It functions flawlessly as a dual warning system.
The exposed marine terrace warns us about the immense power of the past, proving that catastrophic environmental shifts can execute with terrifying speed.
Meanwhile, the fragmented ice sheet above it warns us about the present,
providing undeniable macroscopic proof of the velocity of modern global warming.
For you, as you digest the implications of the Wilczek Island discovery, the core takeaway is the concept of planetary volatility.
We tend to think of the Earth as so slow-moving.
It is easy to fall into the trap of viewing geology and climatology as incredibly sluggish disciplines, where changes only occur over millions of years through imperceptible geological creeping.
But the sudden emergence of this marine terrace, the pristine condition of the cetaceans, and the satellite telemetry capturing an ice sheet snapping in over just 2 decades forcefully disrupt that assumption.
They illustrate an Earth system that is highly reactive and capable of aggressive, sweeping transformations.
It certainly challenges the static way we usually view maps, doesn't it?
Oh, absolutely.
It forces you to recognize that beneath the massive, seemingly permanent white expanses of the Arctic and Antarctic, there are highly complex, lost topographies.
Ancient coastlines, entire forgotten ecosystems.
And stranded apex predators are all simply paused in the dark, waiting for a thermal shift.
As the researchers at the AARI continue their field analysis, utilizing advanced photogrammetry and isotopic testing to determine the precise taxonomy of the cetaceans.
And the exact timeline of the stranding.
Right. We will inevitably gain a much sharper understanding of the localized mechanics of that ancient sea level event. Every fragment of bone they extract from that permafrost margin refines our climatic models.
We have navigated through some intense scientific terrain today, from the howling winds of Wilczek Island and the thermal dynamics of a fracturing glacier to the supertidal flats of the Atacama Desert.
And the profound anthropological engineering of the Yupik people.
We've seen how the loss of over 6.5 million tons of ice in just 2 decades can suddenly crack open an anaerobic vault containing thousands of years of biological history.
It is a massive amount of data to process.
It is, but parsing through it is essential for understanding the highly volatile, beautifully complex planet we inhabit.
The cryosphere has always been our most accurate record keeper, and right now the thermal degradation of the Arctic is forcing those archives to spill open.
Thank you for joining us on this deep dive. We hope you walk away with a sharper, more nuanced understanding of how intricately our paleoclimatology, our active geology, and our modern climate trajectory are interwoven.
It's all connected.
It is. Before we sign off, we want to leave you with one final, lingering concept to analyze on your own.
Something to really think about.
Consider the mechanics of what we discussed today. If a sudden, violent environmental shift thousands of years ago was capable of lifting the seafloor fast enough to strand massive apex predators on a hidden terrace.
And today's climate is warming aggressively enough to structurally shatter the glaciers hiding them in under 20 years.
What other massive, perfectly preserved biological or geological anomalies are currently trapped just beneath the degrading permafrost margins, just quietly waiting to completely rewrite our baseline understanding of Earth's timeline?
That's quite a thought.
Keep wondering, and we'll catch you on the next deep dive.